Have you ever wondered how headphones work? How does that tiny device produce such clear and loud sound? Those tiny contraptions that we plug into our ears or place over them, they're more than just a means to listen to our favorite tunes. They're a gateway to another world, a world of sound. Here's a fun fact. Headphones have been around for more than a century. They've evolved from bulky devices used by telephone operators and radio stations to sleek, stylish, and compact gadgets that fit into our pockets. Headphones, earphones, earbuds, in-ears, over-ears, on-ears. The list goes on, each with its unique design and purpose. Some are tailored for music production, others for gaming, and some for just enjoying our favorite beats on the go. But have you ever stopped to ponder how they work? How do these small devices manage to recreate the entire audio spectrum? Well, prepare to have your curiosity satisfied. Let's unravel the mystery behind these everyday devices. To understand how headphones work, we first need to understand sound itself. Sound in its most elemental form is the vibrational motion of particles in a medium, usually air. Imagine plucking a guitar string. The string moves back and forth rapidly, causing the surrounding air particles to do the same. This movement propagates outwards in a wave-like motion, creating what we know as sound waves. These sound waves travel through the air until they reach your ears. There, they encounter a marvelous bit of biological engineering, your eardrum. Your eardrum is a sensitive membrane that vibrates in response to these sound waves. These vibrations are then transmitted to tiny bones in the middle ear, which in turn stimulate the cochlea, a spiral-shaped organ filled with fluid and sensory cells. These sensory cells send electrical signals to your brain. Your brain, the ultimate interpreter, then processes these signals, transforming them into what we perceive as sound. Whether it's a symphony orchestra playing a Beethoven masterpiece, your favorite pop song on the radio, or the voice of a loved one, it all boils down to these vibrations and how your brain interprets them. But how do headphones fit into this picture? Well, headphones essentially replicate this process in a compact form. They generate sound waves, create vibrations, and deliver these directly into your ears. Instead of a guitar string or a human voice creating the vibrations, however, it's the tiny speakers in your headphones doing the job. Headphones allow us to experience sound in a personal and intimate way. They can transport us into different sonic worlds, whether it's the heart-thumping bass of a live concert, the delicate nuances of a violin solo, or the immersive soundscape of a movie, all thanks to the magic of sound waves and vibrations. So how do headphones create these sound vibrations? Let's find out. At the heart of your headphones are two crucial elements: magnets and electricity. But how do these two seemingly disparate components come together to create the music that fills your ears? Let's start with the magnets. In your headphones, you'll find small permanent magnets. These aren't the kind you'd stick on your fridge, but rather highly potent magnets designed to interact with electric currents. They're stationary, providing a fixed magnetic field in the heart of the headphones. Now let's bring in the electricity. A coil of wire within your headphones, known as the voice coil, carries the electric current from your device. As the current flows through this coil, it creates its own magnetic field. This is where the magic happens. The magnetic field generated by the electric current responds to the permanent magnet's field. Depending on the direction of the current, it's either attracted to or repelled by the permanent magnet. This push and pull, this dance of attraction and repulsion causes the coil and an attached component known as the diaphragm to vibrate. These vibrations are crucial. They're not just random movements. They mirror the original sound waves of the music or podcast you're listening to. As the diaphragm vibrates, it pushes and pulls the air around it, creating pressure changes. These pressure changes move through the air as sound waves, which travel into your ears, hit your eardrums, and voila, you hear sound. In essence, your headphones are converting electrical energy into mechanical energy, which is then transformed into the acoustic energy that we perceive as sound. It's an intricate ballet of science and technology happening right in your ears every time you press play. So we've seen how headphones use electricity and magnets to create sound, but how does this all fit into such a small device? The clever design of headphones allows all this sound generation to happen in a tiny space. Let's dive into the structure of headphones to understand how they create the sounds we love. Headphones, as small as they are filled with complex components that work in harmony. The major elements are magnets, voice coils, and diaphragms. Starting with the magnet, this is a permanent fixture in your headphones. Its main purpose, to create a magnetic field. This isn't just any field, but a consistent one that plays a crucial role in the production of sound. Next up is the voice coil. This component is a thin wire loop that's delicately wound and placed within the magnet's magnetic field. When electricity from your device flows through this coil, it becomes a temporary magnet with its own magnetic field. This causes the coil to oscillate back and forth, reacting to the magnetic field of the permanent magnet. Now, let's talk about the diaphragm. This is a thin, flexible membrane usually made of paper, plastic, or metal. It's connected to the voice coil and moves along with it. As the coil oscillates back and forth, so does the diaphragm, and it's this movement that pushes and pulls the air to create sound waves, which our ears perceive as sound. So, in essence, the magnet establishes a magnetic field. The voice coil reacts to this field with its own, and the diaphragm vibrates to create sound waves. It's a symphony of physics, all happening inside your headphones. All these components and their functions are crucial in the production of sound, but they also work together in a finely tuned balance. Each part must function correctly and in harmony with the others for your headphones to produce the high-quality sound you expect. But wait, there's more. While this explains how headphones produce sound in general, it doesn't explain how they can produce different sounds and notes. So the design of headphones allows them to produce sound, but how do they produce different sounds and notes? Well, that's a question for our next scene. The magic of headphones lies in their ability to produce a range of sounds and notes. This diversity of audio experiences, from the low hum of a bass guitar to the high trill of a flute, is all thanks to the varying electric currents flowing through the headphone's speaker. So let's dive a bit deeper. Every sound in the world, every note in a song has a unique frequency. This frequency determines the pitch of the sound. High frequencies correspond to higher pitches, while lower frequencies produce lower pitches. In headphones, these frequencies are represented by the speed at which the speaker vibrates. A high frequency makes the speaker vibrate quickly, creating a high-pitched sound. Conversely, a low frequency slows down the speaker's vibrations, resulting in a low-pitched sound. But it's not just about the pitch, is it? The volume of the sound also plays a crucial role in our listening experience. This is where the amplitude of the electric current comes in. When the amplitude is high, the speaker vibrates with greater intensity, producing louder sounds. When the amplitude is low, the speaker's vibrations are less intense and the sound is softer. So, in essence, your headphones are constantly adjusting the frequency and amplitude of the electric current to reproduce the full range of sounds and notes in your music or podcast. It's like having a mini orchestra right in your ears, with the speakers acting as the musicians playing different notes at different volumes, all at the command of the electric current. But remember, while it may seem straightforward, this process is occurring at an incredibly rapid pace, with the speaker adjusting its vibrations thousands of times per second to recreate the complexity of the audio. It's this rapid, precise adjustment that allows your headphones to deliver the rich, immersive sound experience that we all enjoy. So that's how headphones work, a simple device with a complex job. From magnets and electricity to sound waves and vibrations, headphones have a lot going on behind the scenes. We've seen how these tiny yet incredible devices convert electrical signals into sound, all thanks to the interplay of magnets, coils, and diaphragms. We've looked at the structure of headphones, understanding that each component has a crucial role to play in delivering the audio experience we enjoy. From the bass notes to the high trebles, it's the design and materials used that shape the sound quality. So, the next time you're absorbed in a podcast or lost in the harmony of a symphony, remember, it's not just about the music or the content, but also the marvel of technology that's at work. Understanding the mechanics of headphones not only enhances our appreciation for this everyday gadget, but also allows us to make more informed choices when buying a pair. Next time you listen to your favorite song through your headphones, remember the amazing technology that makes it all possible.